Okay, here's a problem that we started in class, and I just wanted to go through the problem so that everyone is clear on what we were doing. So again, this problem reads that Delta Airlines flights from Denver to Seattle are on time 50% of the time. Suppose that 7 flights are randomly selected and the number of on-time flights is recorded. We want to find the probability that at least 6 flights are on time, the probability that at most 6 flights are on time, and the probability that exactly 2 flights are on time. We've deducted that this is a binomial distribution because we have two outcomes. The flight is either on time or not on time. We said that n would equal to 7, right? That's the number of trials. We see that P is 50%, and we're going to find the probability that at least 6 flights are on time. So for problem number 1, we're going to use the binomial CDF, but we looked at another option in class, and I just wanted to make sure everyone was clear on that. So if we were to take all of the probabilities, right, P equals no flights are on time all the way to P, the probability that 7 flights are on time, this would equal to a total of 1. We want the probability that at least 6 flights are on time. So we want the probability that X is greater than or equal to 6. So that means we want the probability that at least 6 or 7 flights are on time. Right? And I can find this probability. I can simply add the probability of 6 flights on time plus the probability of 7 flights on time. All right, so I'm going to add those two probabilities using the PDF because I'm going to find the probability of 6 plus the probability of 7. So I'm going to use that binomial PDF. Right. And again, the parameters are n, comma, p, comma, x. So n is 7, p is 0.5, and we want the number of 6 successes plus, right, that would give me the probability for 6, plus I want the probability for 7. So I'm going to hit normal, or excuse me, binomial PDF. I'm going to put in 7, comma, 0.5, comma, 7, and I get 0.0625. Okay. So this is one way to do it. And if I had a lot of trials, I may or may not want to do it this way, but since there are only 7 trials, I can actually add up the probability for 6 and the probability for 7. If, however, I wanted to use the CDF is going to give me the probability at a number and below. So keep in mind, if the total of probability 0 through 7 is 1, I can take 1, right, which is what all of my probabilities should equal up to, minus the probability from 0 through 5. So in the calculator, using the binomial CDF function, I'm going to put in 1 minus, I'm going to choose binomial CDF. So that's 1 minus. I'm just going to enter in everything in one step. I'm going to put in the binomial CDF for 7, comma, 0.5, comma, 5. Okay. So this is the binomial CDF 7.5, comma, 5. So notice in the binomial CDF function, I didn't actually put in 6 because I want 5 or lower. And when I subtract from 1, that gives me the probability of 6 or 7. Okay. And that was for A. So just keep in mind that the binomial CDF gives you the probability at that number or less. So if we take a look at B, we want the probability that at most 6 flights are on time. So this is probability that X is less than or equal to 6. All right. So if I want the probability that X is less than or equal to 6, I actually want the probability from 0 through 6, right? And I would include 6, right? Because of that greater than or equal to, or that at most 6. So I'm going to put this in as the binomial CDF. N is 7, P is 0.5, X is 6. All right, so again, I'm going to go into distribution. I'm going to find a binomial CDF. 7 is a number of trials, 0.5 is a probability of success, and 6 is the number of successes. And we have 0.992. Okay. And lastly, for C, we want the probability that there are exactly 2 flights on time. So the probability that X is equal to 2. Since this is an exact probability, I'm going to use the PDF. I'm going to put in N, which is 7, 0.5, which is the probability of success, and we want exactly 2 flights on time. So I'm going to go back into distribution. I'm going to find binomial PDF, put in 7, 0.5, 2, and we have 0.164.